Okay, so taking a look at lesson 4, we're going to be reasoning with polygons. So when we talk about polygons, any closed plane figure with 3 or more sides is called a polygon. When all its sides are equal and when all its sides are equal and all its angles are equal, we call it a regular polygon. So like a equilateral triangle, where if these were all the same and all these sides were the same, we'd call that a regular polygon. If all of its angles and all of its sides are not equal, we call that a irregular polygon. Polygons have special names according to the number of sides. So if it's 5-sided, it's a pentagon, 6-sided is a hexagon, and we know most of these. Regular polygons can be constructed inside a circle, as shown below. So, in all these cases, I've constructed it inside of a circle, and I just go from one edge of a circle to another edge, and then back. So here I have my triangle, I have my square, I have my pentagon, hexagon, and septagon. Sorry, this case is an octagon. All right. So the diagrams above show some regular polygons. Complete the table to determine the measure of the interior angle of each polygon and the sum of the measure of interior angles in each polygon. So we're talking about the interior angle. Then we're just talking about from one side to another side. If these are all regular, then all those angles will be the same, or the sum of adding all 3 of those angles together. In this case, all 4 of those are going to be the same, or I can do the sum of it, so on and so forth. So, if I'm going through the list, well, the first one is a triangle, it's told us. It has 3 sides. The measure of the central angle going all the way around the center point is going to be 360 degrees divided by the number of sides it has, which means that if I look in here, then each one of these angles is going to be 120 degrees. And if I take the 180 for the triangle I've created here, minus that 120 and divided by 2, then I'm going to get what this isosceles triangle is, which is going to state that this small angle in here is going to be 30 degrees, same as this one. And then I'm going to double it again to get what the entire interior angle is, which is going to be 60 degrees. If I add up all 3 of these 60-degree angles, it's going to give me 180 degrees. They did the same thing with 4. They took, going all the way right around the circle is going to be 360. Split it into 4 sections, 1, 2, 3, 4. And I know that each one of those angles is going to be 90, which means that this isosceles is going to be 45 and 45, or the interior angle is going to be 90, and when I add up all 4 sides, or all 4 angles, it's going to give me 360. So, if I have a pentagon, I have 5 sides, which means I'm going to take 360 divided by 5, and that's going to give me 72 degrees. If I take that 180 minus the 72 and divide that by 2, then the isosceles triangles inside are going to each add up to 54 degrees. And when I double that 54 degrees, then the interior angles inside of this are going to be 108 degrees. And if I have 5 angles inside of here that are all 108 degrees, this is going to add up to 5 times 108, or 540 degrees. If I am looking at a 9-sided one, then I'm going to go 360 divided by 9, and that's going to give me 40. If I take 180 minus 40 divided by 2, then that's going to give me 70 degrees. If I double that, then the interior angles are going to each be 140 degrees. And if I have 9 sides, that means I have 9 interior angles. 9 times 140 is going to give me 1260. If I did a dodecagon, or 12-sided, 360 divided by 12 is going to give me 30. Sorry, I'm going to do this in a different color so it's easier to see. (180 minus 30 divided by 2 is going to give me 75. If I double that, it's going to wind up giving me every single side, or every interior angle will be 150. And if I have 12 sides, then that means I have 12 angles times 150. And all the angles inside of this are going to add up to 1800. So using all this, we're going to solve with our deductive reasoning for how we could solve for any side. So if I take 360 divided by n, that's easy, it's just 360 over n. If I take 180 minus 360 over n, divided by 2, then I can divide both terms by 2, the 180 and the 360, and I'm going to say that that's going to be the same as 90 minus 180 over n. When I double them, then I'm just going to get the 180 minus 360 over n. And when I multiply n sides times 180 minus 360 over n, 180 times n is just going to be 180n. Minus 360, or I could simplify that to 180 in bracket n minus 2. So the total sides inside of a polygon will always be 180 times the number of sides minus 2. Okay. If I'm looking at irregular polygons, so we know that for a regular polygon it's always going to be 180 times n minus 2. Calculating the sum of the measures of an interior angle of an irregular polygon, we can see that in these cases we have some irregular polygons. Choosing a vertex and joined to other vertices, we can split the area of the polygon into non-overlapping triangles. So this one already is a triangle. This 4-sided shape, we just picked one vertex and connected it to another one to create 2 triangles. This 5-sided shape, pick a vertex and split it here, and we wind up with 3 triangles. So let's do the same thing here. We're going to start at this vertex, and we're going to say, okay, well, I can draw it to this vertex, and I have 1 triangle. Down here, and I have 2. Down here and I have 3. Over here and I have 4. And over here I have 5. Which means that now I have created 6 different triangles that are not overlapping. If I did the same thing here, I can create 1, 2, 3, 4, 5, 6, 7, and 8. So based on the number of sides, if I have 3 sides, I can have 1 non-overlapping triangle, which means that the sum of the interior angles is going to be 180 times 1, or just 180. If I have 4, then I'm going to have 2 non-overlapping triangles, like we see up here. 2 times the total of the triangle, 180, is going to give me 360. If I have 5, then I can see I have 1, 2, 3 non-overlapping triangles, and 180 times 3 is going to give me 540 degrees. If I had an octagon, then it's going to be 8, which means that when I look at the pattern, it's always 2 less. The number of triangles is always 2 less than the number of sides, so I'm going to have 6 sides, and 180 times 6 is going to give me 1080. If I have that decagon, then I'm going to have 10, which means it's going to create 8 triangles, and 180 times 8 is going to give me 1440. If I had a 100-sided polygon, then I'm going to have 98 triangles. 180 times 98 is going to equal 17,640. Or if I had an n-sided one, the number of sides is n, the number of triangles is going to be n minus 2, which means that it's going to be 180 times n minus 2 degrees, which is the exact same thing we found with the regular polygons. The work on the previous page shows that the sum of the measures of interior angles of an n-side irregular polygon is also 180 times n minus 2. So no matter what it is, if I have an n-sided polygon, it's always going to be 180 times n minus 2. Now, if we're extending that concept, since there are n equal sides to any regular polygon, the measure of each angle is going to be the total angles divided by the number of sides, because the number of sides is going to match the number of angles inside. Or if I divide everything by n, I can simplify it to bracket 180 minus 360 over n. It's going to give me the same thing. So we can say that the interior angle of an n-sided regular polygon is going to be 180 minus 360 over n for that interior angle. Since the exterior angle is supplementary to the interior angle, if I took that interior angle and continued it on out here, then the two of them are going to have to add up to 180. So if I had 180 minus the interior angle, then it'd be 180 minus 180 minus 360 over n. Well, the 180s will cancel out, which means this outside or exterior angle is literally just 360 over n.